What a nice day to harvest today. Oh yeah, I should probably note down how much I harvested. Alright, cool. A few years later. Hi, we'd like to ask a few questions for our census, so here's the survey form. It'll be great if you could help us fill it out. These census surveys happen once every 10 years, and are usually conducted through pen and paper interviews. These censuses are used to collect key indicators that help inform policies. This, however, has a few issues. First, the data is just collected too infrequently, which results in outdated data. And number two, farmers who don't do things formally tend to keep records of things informally, either through notes or through memory. In our case, we spoke to a few farmers who noted that they keep track of things either through taking down notes on a notebook or a whiteboard. These informal notes actually contain information that is trying to be obtained through the census. So we asked ourselves, what if there's a way to capture it and then digitalize it? Like how people tend to keep digital copies of their receipts for tax purposes. When scouting around to see if there were already readily available solutions, we only found tools like optical character recognition that extracts text. However, this has a few issues. Namely, there's no validation after the text is extracted, so if there are any errors, there's no way to correct it. And number two, text extraction is just text extraction. There is no actual understanding of what the content is, or how the output text should be structured. For example, how would you know that papaya is related to a certain irrigation date that you've written down in your notes if it's not specifically structured in a way that can be manually formatted after the text is extracted? We decided to look into the use of LLMs as a post-processing tool, as it had a few capabilities that were desirable. First, it can understand semantically what the farmer is trying to write. So in unstructured documents, it can actually understand the relationship between words in the extracted text. Secondly, it has the ability to correct misspelled words, and validate whether the extracted text actually makes sense. Thirdly, it can perform translation jobs and formatting, which helps keep the data clean and easy to use later on. So what we've created is an application with the following pipeline. There are 6 main stages: capturing, extracting, interpreting, formatting, validation, and storage and retrieval. The most novel part of our solution is the interpreting, formatting, and validation stages. We built this processing pipeline using GPT Vision from OpenAI and GPT 3.5, which is fine-tuned on agricultural data examples, to help the model understand contextually that it's dealing with agricultural data in the form of written notes. The interpreting, formatting, and validation stages are all handled by the large language model. Text extraction applications that are built using this pipeline can now extract the desired key information while having the output be logically structured.
Okay, let me just check it out in my logbook. Alright, everything's here.